Welcome to this video. In this video, we'll solve a trigonometry problem. What's the question? The question is, you have to prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1 is equal to 1 divided by secant theta minus tan theta. This is what we have to prove. And we are supposed to prove this using an identity, which is tan square theta plus 1 equals secant square theta. Let's see how to do this. This is the entire solution from A to in first step to the last step. We start from LHS and we prove that it is same as RHS. Okay, let's look at each of the steps. The first step is what we do is, because the LHS happens to be in sine and cos and the RHS happens to be in secant and tan, we try to convert sine to tan. Usually you do the other way around, but in this case, the question specifically asks us to use the tan square plus secant square identity. That's the reason why we convert sine to tan. Okay. So what we do is we just divide sine minus cos. We divide numerator and denominator with cos and we get this. Let's see how that happens. So if you look at it, it is sine theta minus cos theta plus 1 divided by cos theta. And sin theta plus cos theta minus 1 divided by cos theta. So all we have done is taken numerator and denominator and divided by cos theta. That's all we have done. This can be further simplified as sin theta by cos theta minus cos theta divided by cos theta plus 1 by cos theta. All we have done is we have individually broken these terms and divided by cos theta. Okay. So if you simplify this, what do you get? So sin theta cos theta is tan theta, right? Sin by cos is tan. Cos by cos is minus 1 because you cancel cos and cos. And 1 by cos theta is secant theta, right? So that's what we get. And the same thing we do with denominator. As a result, you end up with tan theta plus 1 minus secant theta, which is this step. So basically, we have divided the whole thing by cos theta and we got the next step. Now what do we do here? We're just rearranging the terms. So we move the secant theta next to the tan theta. So you have tan theta plus secant theta. So it's just rearrangement. Okay, we're not doing anything else here. Why we're rearranging is because we want to eventually multiply it by tan theta minus secant theta. So that is why we're rearranging. Let's look at the next step. What are we doing here? We are multiplying both numerator and denominator with tan theta minus secant theta. Why we do this, you will see later. So that's what we're doing. We're just multiplying numerator and denominator by tan theta minus secant theta. Then we only simplify the numerator. We don't simplify the denominator. When we simplify the numerator, what you see is tan theta plus secant theta. We multiply by tan theta minus secant theta. Okay, so this is like a plus b multiplied by a minus b. You end up with tan square theta minus secant square theta. So it's like a square minus b squared, right? So a plus b multiplied by a minus b becomes a square minus b squared. So that's what we're doing here. So that becomes tan square minus secant square theta. The rest of the term, where we multiply minus 1 with tan theta minus secant theta, we leave it as it is. So we just don't do anything there. We just leave it as it is. So that's what happens here. Okay. So if you look at the whole thing here, what we did, we took the term, we separated the tan theta secant theta part, multiplied with tan theta minus secant theta, and we got tan square minus secant square theta, and the minus of 1 multiplied by tan minus secant theta, we leave it as it is. So let's go to the next term. This is an interesting bit. This is where we actually use the identity. So what does the identity say? The identity says that it is tan square theta plus 1 equals secant square theta, right? That's the identity. And if you rearrange the terms, in other words, bring the secant square theta to the left-hand side, plus 1 to the right-hand side, you end up with secant square theta having a negative sign. So it becomes tan square minus secant square theta, plus 1 going to the RHS and having minus 1. So in other words, we can replace this tan square theta minus secant square theta with minus 1. This is what we have done here. And the next term, all we have done is we just multiplied the minus and got minus tan theta. So minus of plus is minus, minus of minus is plus. So that's plus secant theta. Now if you notice, the denominator term and the numerator term are the same except for the sign. So if you really look at it, if you take the minus 1 out, they are exactly the same. In other words, you can cancel the numerator and denominator and we'll end up with minus 1. Okay, so all we have done is taken minus 1 out, cancel numerator, denominator, you get minus 1. Now, we have to get rid of the minus 1 because what we want is secant theta minus tan theta. So what we do is we just multiply both numerator and denominator with minus 1. And what that does is in the numerator you end up with 1 and the denominator you end up with negative of this, which is secant theta minus tan theta. Which is what we wanted to prove, which is the RHS. As you can see, this is the RHS. In this way, we could actually prove that this entire expression is same as RHS. Hopefully you understood how to solve this problem. Let's solve a different problem in the future video. Till then, bye. Thanks for watching.